If the polynomial has real coefficients and any of the zeros are complex numbers with imaginary parts, then the conjugates of the complex zeros also have to be 0. You know that if you multiply conjugates, binomials that are identical except one has a plus and one has a minus in the middle, when you multiply conjugates, if I FOIL this out, I will get a squared minus ab plus ab minus b squared. Middle terms will cancel each other out, and all you ever end up with is the first one squared minus the second one squared. So if we have x plus 3 times x minus 3, a sum and a difference of the same terms, this is what conjugates are, we're going to end up with x squared minus 3 times 3 is 9. So anytime we multiply two conjugates together, we will end up with the first one squared minus, because it has to be a plus times a minus, minus the second one squared. So this is going to be x squared minus 3 squared. If two of the zeros, 2 in this case, have imaginary parts and the coefficients are only going to have real numbers, then there has to be something to cause the imaginary parts to get canceled out, and this is the only way that can happen. So one of the zeros is 0, so the factor is just x minus 0, or x. The second 0 is a positive 2i, which means the factor is going to be x minus 2i. But since we know we have real coefficients, we also have to have x plus 2i as another factor. Since the next 0 is 4 plus I, then the factor is x minus 4 plus I. And I would have to carry the negative through, except that the conjugate of this is 4 minus I. So we've also got x minus 4 minus I. So we don't have to worry about carrying the negative through, because we're also going to have 4 minus I as a 0, just like here we had a negative 2i. Don't change the sign in front of the 4, you change the sign in front of the imaginary part. The conjugate of 4 plus I is 4 minus I. The conjugate of 0 plus 2i would be 0 minus 2i. Now when you multiply these out, when you multiply these two out, because these are conjugates just like these were conjugates, we're going to end up with the first one squared. So we get x squared minus the 2i squared. So this is going to turn out to be x squared minus 4i squared. And since I squared is -1, minus 4 times a -1 would be a plus 4. So this is actually going to turn out to be x squared plus 4 multiplied out. When you multiply regular real numbers, you get the minus the square. But when you square an imaginary number, it changes to the negative, and minus the negative always becomes a positive. This is why if we were to solve x squared plus 4 equals 0, and we get x squared equals a negative 4, so x is going to equal plus or minus the square root of a negative 4. X would equal plus or minus 2i. There they are. Now this works pretty much the same way, except that instead of breaking the factor up and thinking of it as x minus 4 plus I and x minus 4 minus I, I'm going to break it up here where the sign changes. So I'm going to think of this as x minus 4 plus I and x minus 4 minus I, because this now gives me conjugates. I've got x minus 4 plus and minus I. So it multiplies out to x minus 4 squared, the first one squared, minus the second one, I squared. Well, x minus 4 squared, when you FOIL it out, will become x squared minus 4x plus 4. Minus I squared is actually the same thing as a plus 1 because it's minus negative 1. So this is going to be x squared minus 4x plus 5 times x squared plus 4 times x. Now let me erase all this over here so I've got more room to finish multiplying this out. So I've still got 3 things to multiply out here. I've got this times this times this. So I've got my x sitting out here in the front. Now I've got x to the 4th minus 4x cubed plus 5x squared. And now 4 times each of these is a plus 4x squared, a minus 16x, and a plus 20. So I've still got this x out front. I've got 1x to the 4th term. I have a single x cubed term, so minus 4x cubed. I have only one x squared term, plus 4x squared. 2x to the 1st, so positive 5 and a negative 16 would be a negative 11 x's. And then the plus 20. And then I'm going to multiply through by this x from the beginning. It's just going to increase all of my exponents by 1, so x to the 5th minus 4x to the 4th plus 4x cubed minus 11x squared plus 20x. So this would be the most basic polynomial with the smallest degree possible that would have these 3 zeros. Because if it has these 3, it has to have 5, the conjugates of the 2 imaginaries.